Hi students, today we are going to discuss about the angle of deviation produced in a prism, and hence we are going to derive an expression for the refractive index of the material with which the prism is made up of. So here the material is glass. So for glass, how to determine the refractive index? Now for that I have considered A, B, C is the principal section of a prism. So that the surface AB is a refracting face and AC also is a refracting face and BC is the base. So this BC is called the base of the prism and this is a non-refracting. So the surface AB and AC are the refracting faces. Now I have considered a ray of monochromatic light. You can see PQ is the incident ray. It is monochromatic, that means it has a single wavelength and color. So when it is incident on the glass prism on the face AB at the point Q, it is deviating from its original path. It is unable to travel along the same straight line. Can you see that P, Q, E, F is the extended direction of the incident ray. So the moment light enters inside this glass, it is unable to travel along the same straight line. It is deviating from its original path. This deviation only is called as what? Refraction. So the angle made by the incident ray PQ with the normal at the first surface is angle of incidence I1, and for this PQ incident ray the corresponding refracted ray is QR inside the glass. QR is inside the glass and it makes an angle with the normal. This is called as angle of refraction R1. This is R1. Okay, angle RQO. RQO. So this is the angle made by the refracted ray QR with this normal. So R1 is the corresponding angle of refraction. So I1 is the angle of incidence and R1 is the angle of refraction at the first surface AB. So here the refraction is taking place when light travels from air into glass, air to glass. Once again the light has to come out of the prism, is it not? So through which phase it is going to emerge out is the phase AC. So now the light has to travel from glass into air, from a denser medium into a rarer medium. So another refraction is going to take place at the surface AC. Okay. So here you can see for the second refraction at the surface AC, QR is the incident ray and RS is the refracted ray. So the angle made by this QR with the normal N dash, with the normal. So this should be the angle of incidence for the second phase, and this angle made by the ray RS, refracted ray RS with the normal N dash, this must be what? Angle of refraction. Is it not? For the angle of incidence at the first surface we have used a symbol I1, and the angle of refraction at the first surface we have used a symbol R1. So here naturally we are supposed to use the symbols I2 and R2 only. Is it not? So this QR makes an angle I2 here and RS makes an angle R2 here actually. But the second refraction is taking place from glass into air, while the first refraction is taking place from air to glass. Is it not? So I will take the principle of reversibility of light. That means if the ray of light enters inside this glass prism from S to R, if the light enters means then in which direction the light should have traveled inside the glass prism? Definitely it should have traveled from R to Q only. Is it not? Okay. So when the light enters from S to R, then the refracted ray must travel from R to Q inside the prism. This is called principle of reversibility of light. So I am going to use here the symbol I2 and here the symbol R2. But in the examination, what we are going to write, first below the diagram we have to mention what is I1, I2, R1 and R2. So I1 is the angle of incidence, okay, at the first surface, and R1 is the angle of refraction at the first surface. Similarly, R2 is the angle of incidence, understand, at the second surface, and I2 is the angle of refraction. But actually, this I2 is the angle made by the final ray, emergent ray, RS, with the normal. And hence, I can also call this angle I2 is equal to angle of emergence E. Understand that? So, first we have to give an introduction about what is I1 R1 and R2 I2. Okay. Now, you look at the picture once again. How many refractions are taking place in the prism? Actually, 2 refractions. The first refraction takes place from air to glass at the phase AB. So, here you have to observe that by some angle, the light is deviating from its original direction. So, I will call this as D1. So that the deviation, it is called the deviation at the first surface. So, deviation at the first surface is denoted by D1, and certainly that must be equal to I1 minus R1. Okay, then the light travels along the path QR, and once again it is bending down along the direction RS. So if RS is produced backward, means you can see that here there is another angle of deviation D2. So there is another deviation on the second surface AC. That is deviation D2 is equal to I2 minus R2. So how many times the light is deviating from its original direction? When the light is incident on the face AB, once it deviates. Again, when it is incident on the surface AC, another time it deviates. So twice it is deviating from its path. So what should be naturally the total deviation produced? So the total deviation of light. So the total deviation is denoted by the symbol D. So here you can see angle F, E, R. So this is equal to angle F, E, R in this picture, F, E, R. So this is the total angle of deviation D. So naturally that must be equal to what? D1 plus D2. Is it right? Now you carefully watch the triangle here, the triangle QOR and another triangle EQR. On this triangle EQR, this angle D is the exterior angle. I will write here separately in triangle EQR. In triangle EQR, the exterior angle, understand, the exterior angle E, okay, exterior angle E is equal to sum of the interior angles, so that is D1 plus D2. So this exterior angle only is the total deviation D, and also it is equal to D1 plus D2. Okay, so D is now equal to D1 plus D2. So instead of D1 I am going to substitute what? I1 minus R1 plus, instead of D2 I can substitute what? I2 minus R2. Now I am going to group the terms, I terms separately and R terms separately. So I am going to write R deviation D is equal to this I1 plus I2 in bracket, I1 plus I2. Then minus is a common factor for R1 and R2. So minus is a common factor. Then into bracket R1 plus R2. So this is our main equation. Okay, this is our main equation number 1. Have you all understood up to this step? First of all, the total deviation produced by the prism is equal to the sum of the deviations produced at surface 1. and at surface 2. That is D equal to D1 plus D2. And now in the diagram, you try to notice one triangle QOR. QOR. This angle is R1 and the opposite angle is R2 and the third angle is QOR. So, the sum of the three angles in triangle QOR, the sum of the three angles, namely R1 plus R2 plus angle QOR is equal to 180 degree. So, this is equation 2. Now, you try to notice this quadrilateral A, Q, O, R, A, Q, O, R. So this angle is 90 degree and this angle is 90 degree. So the internal angles also will be 90 because it is normal. So the remaining two angles, namely angle A and angle QOR, angle A and angle QOR, the sum must also be equal to how much? 180 degree. So I will write now here in quadrilateral AQOR, the sum of these two opposite angles A plus angle QOR must also be equal to 180 degree. Why it must be equal to 180 degree? Because the other two angles are already 90 and 90, 180. The total angle in a quadrilateral must be equal to 360 degree, is it not? So if two angles are already 90 plus 90, 180 means definitely the third side, the third and the fourth angle must be equal to 180 degree. So here A is the angle between the two refracting faces. So this A is called the refracting angle of the prism. We have studied in the theory, is it not? So A is called the refracting angle of the prism, and this is now equation 3. So the right hand sides of equations 2 and 3 are equal, 180 degree. Therefore the left hand sides must be equal. Okay, so A plus QR is equal to 180. Here R1 plus R2 plus QOR is also equal to 180 degree. So from equations 2 and 3, from equations 2 and 3, this angle A must be equal to R1 plus R2. A is equal to R1 plus R2, and this is equation 4. So you can see here this equation 1, deviation D is equal to I1 plus I2 minus R1 plus R2 is there. In place of R1 plus R2, what shall we substitute now? You tell me. In place of R1 plus R2, I am going to substitute capital A. Okay. Therefore, deviation D is now equal to I1 plus I2. Okay. So this is I1 plus I2 minus capital A. So this is equation 5. This is the required equation for the angle of deviation produced by a prism. D is equal to I1 plus I2 minus A. Understand? So here D is the deviation which depends on the angle of incidence I1, and D is the deviation which depends on the angle of emergence. I2 is what? Angle of emergence. And A is what? The angle of the prism. So deviation also depends on what? The angle of the prism. So from this equation 5, we understand that the deviation produced by a prism depends on these three factors, namely angle of incidence, then angle of emergence, and angle of the prism. In addition to that, this deviation also depends on the wavelength of light. Understand? Here we are discussing about what? Monochromatic light of a definite wavelength lambda. That is the fourth factor on which the deviation depends. So you have studied already, is it not, when white light, which is polychromatic light having 7 different wavelengths, when it is incident on a prism, dispersion will take place and the deviation is maximum for violet and least for red. It means what? The deviation depends on the wavelength of light also. You must remember. Okay. Now I am going to draw a graph between the angle of incidence and the angle of deviation, and this curve is called as ID curve. Okay, this curve is called as ID curve. So I will take the angle of deviation along the y-axis and the angle of incidence along the x-axis. So this is the plot of a graph between the angle of incidence and angle of deviation. So if you plot a graph means you will see that the nature of the graph will be like this. Okay, this is the nature of the graph. So from this graph we find that initially when the angle of incidence is increased, when the angle of incidence is increased, you can see that the angle of deviation decreases. Then finally it reaches a minimum most value, and then on further increase in the angle of incidence, we find that the angle of deviation increases again. Understand that? So initially with the increase in the angle of incidence, the deviation has decreased and it has reached a minimum most value. And again on further increase in the angle of incidence, the deviation has increased. Okay, suppose you take a straight line is drawn, okay, parallel to the x-axis like this. So here also another line is drawn parallel to the x-axis. Can you see that the deviation is the same corresponding to two different angles of incidence? So for one angle of incidence I1 and another at angle of emergence I2, okay, you can see the same deviation is being produced. Like that here also for two different values I1 and I2, the deviation remains the same. But can you see this point? So here the straight line parallel to the x-axis is tangential to the point, and this is the point where the deviation has attained the minimum value. The deviation is minimum, okay, and at this point the angle of deviation is denoted with a symbol capital D, and here I1 is found to be I2. That is, angle of incidence is equal to the angle of emergence. So I1 is equal to I2 is equal to I itself, and R1, okay, R1 is also equal to R2 is also equal to R itself. Understand? This will happen only at the angle of minimum deviation. So at this minimum deviation, see here capital D is called angle of minimum deviation. So angle of minimum deviation, and here at this angle of minimum deviation, the refracted ray QR will travel parallel to the base of the prism. So QR travels parallel to, okay, parallel to the base of the prism. In all the other positions, it will not be parallel to the base of the prism. Okay. So now at this minimum deviation position, now I1 is equal to I2 is equal to I, and R1 is equal to R2 is equal to R. Okay, students. Now in the previous equations, can you all see here A equal to R1 plus R2? This is equation 4. So in this equation 4, now I will substitute A is equal to R plus R, that is equal to 2R. Therefore, what is R is equal to A by 2. R is equal to A by 2, and this is equation 6. Similarly, you can see this equation number 5. In this equation number 5, I am going to substitute I plus I. This minus A is shifted to the left hand side. So the same equation 5 becomes A plus this deviation D is equal to what? A capital D, is it not? When the deviation is minimum, it takes a symbol capital D. So instead of small d, I can write capital D. So this is equation 5 I am rewriting. So instead of small d, I have to substitute capital D, and this is equal to I plus I, because I1 is equal to I2 at minimum deviation position. So minus A. So shift this A to the left hand side, or I will shift this 2I. 2I is equal to A plus D, and I is equal to A plus D divided by 2. And this is equation 7. So the previous equations 4 and 5 only take a new form like equations 6 and 7. Are you all feeling that we have substituted R1 is equal to R2 in equation 4 and I1 is equal to I2 in equation 5? Good. So finally we get that angle of refraction is equal to A by 2 and angle of incidence is equal to A plus D divided by 2. Understand? This is in the minimum deviation position. Now we are going to derive an expression for the refractive index of the material of the prism from Snell's law. So do you remember Snell's law? Snell's law of refraction is also called as the second law of refraction. Okay. So from Snell's law of refraction, the refractive index of the prism is equal to sin I by sin R. Sine of the angle of incidence divided by the sine of the angle of refraction. So instead of I, we substitute A plus D by 2. Instead of R, we substitute A by 2. Is it not? Therefore, now N is equal to sine of A plus D, okay, divided by 2, whole divided by sine of A by 2. So this is the final expression of the derivation, equation number 8. So the refractive index of the material of the prism is given by N. Okay, N is equal to sine of A plus D divided by 2, whole divided by sine of A by 2. This is a very, very important derivation and equation. Now if you look at the previous year NEET question paper and JEE entrance also, these equations 4 and 5, after that this equation 8, using these only many problems have come from optics. So you have to remember the base equations 4 and 5. So the angle of the prism is equal to R1 plus R2 and the angle of deviation is equal to I1 plus I2 minus A. Understand? Or this basic equation number 1 also we can remember. So this equation 1, that is the deviation D is equal to I1 plus I2 minus R1 plus R2. Okay students, so what will be the question for 5 marks in the board examination? Derive an expression for the deviation produced by a prism. Hence obtain the expression for the refractive index of the material of the prism. So for that you have to start with a diagram and you have to mention what are the angles I1, I2, R1, R2, what is A, angle of the prism, and then you have to derive up to this equation 5 for deviation, and then you will have to plot the I versus D curve. Based on the ID curve you have to derive the expression for the refractive index of the material. I hope you must have understood thoroughly. Fine.